when you're living within the application layer, you can kind of trick yourself into thinking it's a technical only problem. If only I had better specifications, if only I had better types, if only I had better tests, then no humans would have to talk to each other. You don't have to trust anybody. But I think something that I picked up from the observability world was, look, it's always a people problem. You always have to trust people. And a lot of what the tooling is doing is helping you do archaeology.
Hi, I'm Liz Fong-Jones.
I'm Charity Majors.
And I'm Jessica Kerr.
And you're listening to Observability Cast, or o11ycast for short, a fortnightly series about the art and science of making production systems observable, easy to maintain, and appropriately reliable.
o11ycast is brought to you by Heavybit, a program dedicated to helping startups bring our developer products to market. For more information, visit heavybit.com.
If you're interested in being a guest on this show, or if you have a specific topic you'd like us to dive into, you can reach us on Twitter at o11ycast. That's at o11ycast.
It's been a great transition, lots of fun. But I think it was a surprising transition to a lot of people because before this, I was a professor in computer science working on very academic programming languages. So programming language design, program verification. So how do we prove programs correct? Program analysis. How do we analyze programs for properties? And observability from, afar to many people seems like completely the different thing because a lot of the topics in programming languages, you're playing God. You're saying, okay, here's some specifications. I'm going to prove down to every last atom that, this is doing exactly what I said it would do. And
whereas we're like, no. We know that's not the case. Tell us what it's actually doing.
Yeah, exactly. And I feel like especially the brand of observability that Honeycomb champions, it's like, we test in production. We don't even test. So, the world I came from, everyone assumes you write code, you write types, you write specifications, you write tests. And so it's just, on the one hand, it seems like such an opposite world, but I had been very seduced by reality. And so, here I was in the ivory tower, working on tools to make your application level code correct down to the last line of assembly. I literally wrote a paper. The title is Safe to the Last Instruction. It's about verifying assembly code. And, that's all fine and good if you're running a rocket ship, if you're Amazon and you're like running everything down to the metal and the rest of the internet depends on you. But for the vast majority of web app companies out there, that's just not the case. And so
I would argue that every company, it's just not the case. Like,
yeah.
Production has a way of messing with everyone's greatest hopes and dreams.
Yeah.
But this sounds like a good time for you to introduce yourself.
Sure. So I'm Jean. I'm the founder and CEO of a company called Akita Software. We do developer tools. We're in the observability space. I would say we're very complementary to what Honeycomb does. If you want very basic drop-in observability, just start understanding what are your API endpoints, what's in your system. That's what we do.
How do you pronounce your Twitter handle?
It's Jean Kassor. It's
Jean Kassor.
Yeah, JeanQasaur. The backstory is it's a very Asian thing. So I feel like, when you're an Asian American teen, it's a very cutesy thing to use Qs instead of Gs. And I don't know, I just started using Qs everywhere because I thought it was so funny people did this. And somehow this became part of my nickname that my friends started calling me.
That's the best place to get Twitter handles.
Well, so what can programming languages learn from observability?
That's a great question. And in fact, ever since I ran away from academia and I started working on APIs and observability, I get asked to speak in classrooms and at grant meetings sometimes. And they're like, Jean, we've been working on, mostly this very top down, specify everything stuff. What should we be thinking about with APIs and things like that? And what I really like about the observability space and especially Honeycomb's work in it, it's just very accepting of, again, reality. And so, you're just like, look, you just can't understand large parts of your system behavior until production. And so I think for me, the big revelations there was I was doing a ton of work on application level tooling. So like language design, program analysis, program verification, they're all assuming that everything happens in the language. But even for me, the cracks were starting to show. You have the runtime, any memory managed language. You have this like giant honking runtime. What are you doing with that? Anytime you call it to the database, you have a bunch of stuff. And like, for me, the big thing that caused me to get into the observability space was network calls, because the bane of my existence, the cause of all of my existential crises was every time you do a network call.
Anytime it hops the network, you're in mystery land. You have no more control over it.
Yeah, you subvert all of your guarantees. So I think the acceptance that you're not going to prove all of that away and you're not going to test all of that away, you can't, I think is one of the big things to learn. And
I think of network calls as being, it really is like reality in operations forcing itself into your gated kingdom or whatever. And that's why like the shift from the monolith to microservices is so fascinating, because, it used to be that, you could kind of believe in a world where there was developers over here and operations over here. But now that you're inserting like network hops and web hops and, you can't live under, every developer has to know a lot more about operations now that it's hopping the network.
Yep, exactly. And I think the big thing is one of the things I love about how you all talk about this is it's a people problem. Because I think that, when you're living within the application layer, you can kind of trick yourself into thinking it's a technical only problem. If only I had better specifications, if only I had better types, if only I had better tests, then no humans would have to talk to each other. You don't have to trust anybody.
Yeah.
But I think something that I picked up from the observability world was, look, it's always a people problem. You always have to trust people. And a lot of what the tooling is doing is helping you do archaeology on what did people do in the past? What did they do recently?
Yeah.
What caused these issues? It's all people.
Yeah.
What was your phrase from Twitter today? Charity, the smallest unit of software delivery is a team.
I love that.
It's not a program. It's not an application. It's a team, which includes some code, but also people.
And it's more than just one person too. Like this is why you can't have a piece of software that is owned by a person, because you've got the bus factor. You can only.
Well, it doesn't even take a bus. You just you're sick sometimes.
Yeah, or you're going on vacation or whatever. Like
you might have a life.
Yeah, good point, Jess.
Yeah, and that's the difference between a program and an application too. You pointed out that a single person can write software. We can write programs. A program can be correct, but a program that isn't hooked up to the network and talking to any person or other program isn't useful.
Yeah.
It's a difference between a program and a software system.
Yep. Yeah, that's a really good way of putting it. And an analogy I like to make is that these software systems, they're like rainforests. They're constantly evolving. There's things coming in and out, especially with microservices and the API economy. This has become very, very apparent.
Even just with like different user patterns starting out, it's like the difference between complicated and complex. With complicated system, like I would say that a piece of code is a complicated system, right? But once it's live, once it's in reality, once it has like users, and traffic patterns and different infrastructure underneath it, it becomes complex, and that means you can't predict what's going to happen when you change something. You have to change it and watch and see what happens under some controlled environment.
Exactly. And I think that a lot of people think of legacy software as some kind of thing that doesn't apply to most companies. The minute you ship code, you have legacy software. There's stuff that binds you. Yeah, you can't change it.
Oh, yeah.
I don't remember things I did last week. And I think that's true of every single person out there that creates code.
This is why, we're all trying to figure out how we can ship more, do more with less, right? How can we ship faster, do better, with the people that we have? Because software as it exists in the wild, you're always accumulating commitments, you're accumulating user pattern, you're accumulating, promises that you've made to people and teams and everything, which means even if you write and ship no code, you're accumulating more to do with the same number of people, like every day that you exist.
Yep. I completely agree.
And then, like you said, as soon as you ship code, that's a promise. As soon as someone else has hit that API, they expect that to still work.
Yeah, which is why I've been on this rampage for the past year about how if you're trying to be a more efficient team, the number one thing you can do is shrink that time. And this is not a novel insight. We've talked about this for years, but it really sunk home for me just in the past couple of years. Just like you were saying, Jean, I don't remember what I wrote last week or last month, right? This is why the cost of finding and fixing problems in our software goes up exponentially the longer it's been since you wrote it, right? And the more you can do to get that fast feedback loop of I'm writing it, I shipped it, and I'm looking at it in production through the lens of my instrumentation and ask myself, is it doing what I expected it to do? Does anything else look weird? If you have that down to, minutes, oh my God, your software is going to be so much better and more tractable and more comprehensible than if you've got a lag time of like weeks or months and the person who's actually trying to debug it isn't even you.
Yeah, absolutely. I mean, that's the sort of thinking that converted me because the assumptions that a lot of people in programming language, formal programming languages make is that the language is the powerful thing. If you just design the language right and you allowed people to say what they wanted,
Right.
And for me, the big realization is there's a huge gap between what you want and what actually happens.
Yeah.
I think for some decades, Gerald J. Sussman, the computer scientist, once spoke in an undergrad class I was taking. And he's like, a lot of people like programming because you can play God. And I think for many decades, systems were small enough. Systems weren't used by that many people and they weren't, hooked up to the internet and all that. You could, for a short period of time, play God as a programmer. And now I think that we have to recognize our humanity again.
Yeah.
Regain the humility that we just have no clue. We have no control over anything. No clue what's going on.
Monotheism is over. Now you have to fight with all the other gods.
Yeah. No, that's so true. And that world where we felt like we had this illusion of control, that's where the great divide between dev and ops came from too. We're like, oh, this is fine. I could, by writing my code and making sure it passes tests, I know it's good.
Yeah.
Someone else can run it now, right? And what we've learned as stuff gets more complicated is that was never true and it's getting less and less true.
Yep.
The people, you have no prayer of running the software if you weren't the person or the team that writes it, that gets inside of it, that looks at it from the inside. You can't just like treat it like a black box to be operated.
Yep.
Part of development is operating it and seeing how it behaves under different systems and constraints. And you're not going to understand your code in the IDE ever.
Yep. I completely agree.
Yeah. And then there's that reality of, okay, but a lot of code, we are running it without the original developers, the capital L legacy stuff.
Yep.
Yeah.
And so, Jean, how does Akita help with that?
We fell into the business of doing that. So I am very transparently, we started out thinking we would do observability for API security. And so as you know, security teams hate invasive installs. They can't get developers to do very much. So we started developing a black box approach for understanding where data was in systems. So that's how we got to our eBPF-based passive network traffic-based approach. We had a lot of stuff that was completely black box, sat outside the system and watched what APIs were doing and told people stuff about it. And what happened was, I think security teams were like, okay, but can you do these 18 other OWASP things? And we're like, no, we just do this one thing, but pretty well. And then developers were like, whoa, if you can actually just drop into my system and tell me about it, I'm actually struggling to log. I'm struggling to put metrics in the right places. And I'm struggling to, find people expert enough to understand how to properly do ops on my system. And so that's how we fell into, proper DevTools observability. And who started showing up? Because our website started out very vague. We were just like something, drop into your system. We tell you stuff about it. But who ended up showing up was people with legacy code. And so an example of one of our users is Flickr. They, they're a Web 2 company. They've been around 20 years. They have this legacy PHP monolith, and they've been breaking it out into services. And that modernization process is so tough.
Yeah.
And, I had a series of conversations with our user there, and I was kind of like, we're such a rough tool right now? Like, why are you in our beta? And he was just like, look, there's not a lot out there. My team isn't big. Nobody on the original code base is still working on the code. And we're just trying to wrap our heads around it.
It sounds like you're using it almost more as a service map.
Yeah. So service map is one part of it. I will say a lot of our users are actually monolith users. So it's initially a discovery tool.
Yeah.
And then it's let me know if anything happens with my endpoint that I want to know about. So a lot of these teams, they're not doing like the very fancy advanced honeycomb level stuff. Like they're not trying to optimize 99th percentile tail latency within every inch of their life. The reason their code has been around for 20 years is it's been mostly okay. But like, how do you still move fast doing that? Let's say you made one endpoint slower. You got to trade that off somewhere else. And so there's a lot of like very high level trade-offs that people make on a day-to-day basis. People still need to make changes. They don't know exactly what the existing system does, what even is talking to what. And so initially, I didn't realize that there was a whole population of developers like this, actually. We just had people starting to show up to our system and we asked them, what other tools do you use? And, it was often very like, it's like a version of that Tolstoy quote. I think, every system that was built in the last year kind of has the same stuff, but every system that was built 5-10 years ago, they're like all old in different ways, like 15, 20 years ago, like the more like every legacy system, I think is legacy in its own unique way. And so for a while, our investors are saying, hey, like what trends are you jumping onto? Or, what star have you hitched your wagon to? And we're like, none. Opposite. Seems like a lot of our users are PHP users.
That's reality.
Yeah. And I think, people had said, look, it's really hard to grow a business with users who aren't growing. And I'm like, we have more and more legacy users showing up. They seem to be there's a lot of them and they're growing some, but it wasn't, us kind of strategically saying, hey, there's this like neglected set of users out there. It was us starting to build under a model and a set of assumptions that we had to be as non-invasive as possible, us developing a set of technology that would allow us to do it, and then developers picking this up and being like, oh my gosh, this is what I've been looking for this slightly other purpose. And so then we just leaned in. We were like, all right, it seems like this is what we're doing now.
So you're using the operating system to spy on like network calls that the software makes?
We're not. So, okay. So like we actually are not even looking at the whole operating system. Like we don't do file system or anything like that. We just do the PCAP layer. So it's just ports, basically. We look at the ports, we watch the traffic. So one way to think about it is it's like Wireshark, but with a whole inference layer on top of it.
The inference layer, does that like notice changes?
Yeah. So first, we infer the structure of the APIs. And so initially we were just like, looking at all the traffic and showing it to our users. And they were like, we were having trouble reading our logs before. This is worse.
Those are all bytes?
Yeah. Well, yeah. We would like just show them like, here's a call, we'd kind of like reify the call a little bit. And so we put in after that a ton of work into inferring paths for URL endpoints, types. So we can actually provide like a pretty concise API model on top of that we automatically infer. And then on top of that, we're able to start inferring changes. So we can detect like very basic things like this was removed.
So do you have something that like a library for people to instrument their code with, or you're just sniffing traffic?
There's no instrumentation. So the challenge that we did was like, how far can we get with no instrumentation? And Charity, you and I have gone back and forth. I completely agree that if you're trying to do anything that like involves like deep debugging, you need to instrument. For us, we're trying to go everything up to like what you don't have to instrument to do. So we can detect endpoint level changes. We can, because we have some inference, we can detect type level changes. We can detect some, performance changes that are externally visible. But for the kind of debugs that you all are working on, we can't do that because we don't instrument.
Yeah, instrumentation is more like, well, to do it, you have to have control over the code.
Yeah.
You have to be able to deploy the instrumentation and hopefully increment on it and make it better. So it's really good for code that you like to some degree have your hands around.
Yep.
Whereas you're working with code that people definitely don't have their hands around.
Yeah, exactly. And I think that there could be like an interesting Akita honeycomb collaboration where, people are trying to get their heads around something. That, we make it really easy for them to drop us and get like a very basic understanding. But, in like year end of this, but what we envision is there's a whole observability stack. What I've noticed is, most companies adopting observability aren't just doing one tool anymore. They have, here's my monitoring for this, here's my,
Yeah, I don't think they want that to be the case though.
Yeah. But I think inevitably, unless someone comes in and unifies it all, there's different tools for different purposes. So I can imagine like us, playing well with honeycomb so that if people are like, okay, now I want to go deeper, I can do some instrumentation or something like that. And that's not what we've been working on at all. We're just like, look, you are in a hole. We will get you out of the hole and give you some basic amenities in life. But, once you get your head around the code, if you want to go deeper, there's a set of other things you can do.
Yeah, like full instrumentation.
Yeah.
And Akita traces or Akita, what do you call them? Events? What do you call the?
Yeah, we've been calling them traces, but it's confusing because they're not observability traces. They're just traffic. They're traffic traces. Yeah.
So that could be linked to a trace that is instrumented around the code.
Exactly. Yeah.
And then you could be like, well, my code says it's doing this, but the network says.
Yeah, exactly. And you can also imagine, feeding honeycomb data into our change inference, like the more source of information we have for that, because like the persona we have in mind is someone who's like, look, I don't have a lot of DevOps expertise or bandwidth on my team. I just need someone to kind of like gut check or, like really flag big things. They might not have the expertise to set up like, detailed dashboards or anything like that. And so we're really just like a very basic starter. This is like.
There's a piece that you wrote recently, something about APIs that I really enjoyed. Do you remember what that was about?
I wrote a few things. One, I wrote the case for developer experience, where I talked about why observability is the thing to work on. That was a few months ago.
Yeah, I liked that one. That wasn't the one I was thinking of.
On the Andreessen blog.
Yeah, I definitely read that one. There was a different one that I was thinking of. This is really cool. We should definitely put this in the notes. The difference between like abstraction and complexity. The one like,
oh yeah,
this is something that Christine and I have talked a lot about in the past, where there are tools that help you back away from complexity and treat things abstractly, and then there are tools that lean into it and help make complexity tractable. And we definitely see honeycomb as being at some point, at the end of the day, somebody somewhere is going to have to understand your code, right?
Yep.
And we're definitely in the business of making complexity tractable for people who have to come up and understand it later on.
Yeah, I love the point that you are in the space. And something that had been really frustrating to me is I think all observability tools are by definition complexity embracing tools. If if people want an easier life, they would just like pay someone to write and run all of their code, and then
it would all be in one app, and then you'd prove it correct.
Yeah, exactly. And sometimes I get so frustrated because I feel like the sexiest demos and, a lot of the dev tools that get a lot of hype, it's like some like TikTok video.
Yeah, it's so easy to fake a demo. It's so easy to make anything look fast or good. This is why, with Honeycomb, we somewhat often run into people who just literally don't believe us. They don't believe that what we're saying about our tool is possible. They think we're lying. They think we're faking our demos,
Yeah.
And I get it. Like if you've lived in a world where high cardinality and high dimensionality, all these things are just impossible, then it sounds like we're just high on our own supply or something.
Yeah.
So it's really satisfying when, one of two things happens. Either, this happened to Christine the other week where she was sitting next to a CTO at some dinner and he's just like, didn't believe it. And she's like, okay. And she talked them through like, well, here's how the column store works. And here's how we can scan so many rows so quickly. Here's how, and that's fun. It's a good way to shut people up, but it's more fun when they actually try Honeycomb on their servers, right?
Yeah.
Try it on their data. And there's nothing, you can see it click in their eyes when they see something that was literally impossible before, and now happens like reliably in sub-second queries on Honeycomb, and you just get the mind blown, and that's really satisfying.
Yeah. No, I think that's amazing. And it's something we struggled with in the beginning because we fell into the trap of like, we have to make such a slick demo. And then we're like, no, like it's never a demo until you're running on their traffic. And actually it isn't a really compelling demo until you're running on their production.
Mm-hmm.
I think that, I would always look at other tools that they're just like, we replaced your backend with a faster backend. Here's a demo. And then everyone's like, okay, I can totally see how that does it. I can imagine it. And I think that complexity embracing tools just have, there's not really a playbook. People forget about us. I feel like, complexity is just something that people so continually sweep under the rug that when people think of buying tools, when they think of recommending tools, it's just
people would be horrified to realize just how many outages, problems, that these large complex systems have are never understood.
Yeah.
How often they happen. We all like freeze, we start looking into it and it resolves itself. And we all sit there looking at each other going, did you see that?
Yeah.
And it's like, okay, we could spend the rest of our day trying to figure it out, or we could just wait and see if it happens again.
Yeah.
Like that's the norm. The norm is not that these things are well understood.
Yeah. So what I like about the observability movement is that, look, like complexity is here. It's biting you. You need to deal with it. This is reality. And here's a better way of dealing with it.
Yeah. Well, and the thing is that there are so many problems happening in most people's systems, like steady state, that they have no idea because they don't happen to, affect like more than 2% of the traffic, or they happen rarely. But like once you have the ability to slice and dice and look beneath the covers, oh my God, there's so much going on. And we have our paging threshold set quite high, which we should, because otherwise being on call would be impossible.
Yeah.
Right? But that just means that there's so many things going on right now that you just have no idea about in your systems.
Yeah, I feel like system monitoring and ops is sort of like where medicine was in the Middle Ages. It's like, okay.
They come armed with like a lance and a leech, and
yeah, the leech is just like waiting.
And then if it fixed it, they take credit. And if not, well, that was just God's plan.
Yeah. And I think that, what I hope to bring to this whole world is a perspective of like, look, I came from a world where there was order. That world happened to be such a small fraction of the whole real world. But, I think there is such a thing as order and more sanity and more structure.
There are systems that are better understood than others, right?
Yeah.
And they're more pleasant to work on. You can do much, you can move much more quickly with much less suffering. I think we've all experienced these systems that they're just like a hairball that some cat coughed up. They've never been understood.
Yeah.
We ship code every day that we don't understand onto the shit we've never understood. And then we wonder why it's like a nightmare to run.
Yeah.
But like when you have a system that is fairly well understood, where you have developers who are checking themselves in the code, it's like night and day.
Where it's last week legacy instead of 3 hires ago legacy.
Yeah.
Exactly.
So my dream is, I used to live in these worlds where we pretended everything was clean and you had full control. And I think there's some kind of, hybrid situation where you have more control over the mess. You don't have full control. And so, going the other way, what I think observability can benefit from with programming languages ideas is the spirit of all the work I did was we take messy, complex systems and we bring order. And what I thought was unfortunate was no one was bringing that much order to real systems and ops. And so, to me, logs are like assembly. They're low level. You can do anything with them, but what can we extract from logs? What kind of insights? What kind of questions do people really want to be asking about them?
Logs are just spaghetti strings. They should be deprecated. Nobody should be logging unless you're in a development environment.
Yeah. Right. And so like, where can we raise the abstraction from logs, metrics, and traces? That's been the big challenge we've set out for ourselves.
To events.
Yeah.
From the perspective of the user.
Yep, exactly.
Because we can't have complete order. We have to give up as soon as the network is involved on having perfect guarantees. But that doesn't mean we can't have some.
Yeah.
We can have more clues, more tools to detangle the hairball.
It can be better.
Yeah, never going to be perfect, but it can be a whole lot better.
That was a delightful conversation that I enjoyed and hope you did too. If you're interested in being a guest on this show, Or if you have a specific topic you'd like us to dive into, you can reach us on Twitter at o11ycast. To learn more about Heavybit, visit heavybit.com, and while you're there, check out their library. It's packed with amazing talks on sales, marketing, product, and general management from founders of developer tools companies and other industry leaders. Hope to see you next time.